Good morning or afternoon, whichever time you're checking this. Today's notes is working with section 1.3, ruler postulate, segment addition postulate, and midpoint of a segment. Those are the things we're doing, but we're going to have to pay attention to notation. So postulate 1.5, ruler postulate. Every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on the line and the real numbers. One-to-one means there's exactly one number for every point on the line. Everybody has a partner. Okay? The real number that corresponds to the point is called the coordinate of the point. Now, we're going to talk about this being the point A and our coordinate being small a, which represents a value, a number on the number line here, which is a ruler, and B, which represent, as a point in the B, which is a number on the number line. Notice here that I have A, B, capital A, B mushed together. It means the distance between A and B. Now, I can take the absolute value of the difference, A minus B, or I could do the absolute value of B minus A. The reason why I worry about that is I don't have to worry about the order. It'll always be a positive length. Now, if we're going to find the distance, you got to make sure you pay attention to this. I'm going to actually use the notation they ask us to use. I do this because we're going to be working with distance formula. So I'm going to find ST, which is S and T, 8 minus a negative 4. Well, 8 minus negative 4 will give me a 12, absolute value of 12, which is just 12. Now, if I flip-flop this, it'd be negative 4 minus 8, which would be negative 12, and then I'd still have 12 after I took the absolute value. I'd like you to make sure you're showing your notation. This is TU. Remember the distance between T and U. There's nothing on top. Okay, when it's just naked like that, capital T, U mushed together, it's the distance between T and U. Well, T is 8, U is 10, 10 minus 8 is 2. Okay, find the distance between U and V. You go ahead and find the distance between U and V, T and V, and S and V in the last three, and then turn it back on. Okay, now you've had time to work with this. We've got UV is 14 minus 10, which distance is 4. We have TV. Now you could have gone 8 minus 14 or 14 minus 8, and you could have come up with 6 either way, whether it would be absolute value of negative 6 or absolute value of 6. Remember, the absolute value notation's there for us to get used to it and understand that when the order is flip-flopped, and I'm talking about distance, I'm going to have that positive answer come out. The distance between SV is equal to the absolute value 14 minus a negative 4. Well, V is 14, S is negative 4, and their difference is 18. Now going on, postulate 1.6, segment addition postulate. Please notice again the notation. A and B, capital A, capital B mushed together. Capital B, capital C mushed together. That represents the distance between A and B. These points A and B, this is the distance A and B, and this is the point B and C, and this is the distance B and C. You will be tested on this notation, so pay attention to it. And remember, B does not have to be a midpoint. It's just a point somewhere between A and C. So the 3 points A, B, and C are collinear, means they all line up on the same line, and B is between A and C. Then AB, the distance between A and B, BC, the distance between B and C, is equal to AC, the full distance of the segment. Now remember, the notation here is very, very descriptive. It's talking about the distance between 2 points instead of just a variable. Okay, so now let's look at some example problems with this. If I have EG, that's the full length is 59. What are EF and FG? Well, EF is 8x minus 14. FG is 4x plus 1. So I'm going to represent this as EG is equal to EF plus FG. Now I could have flipped it around the other way, but I wanted to make sure that you notice that I'm going for the whole length. Well, the whole length is 59, and EF is 8x minus 14, and FG is 4x plus 1. Now, at this point, after I plugged everything in, it's just combining like terms and solving for x. So now I get those terms combined. I get 12x minus 13 equal 59. I add 13 to both sides. I get 72 equals 12x, and then divide by 12, and I get 6 equal x. Well, that is not my answer. I found out that x is 6, so now I must plug it back in to find the actual length EF and FG, because here they're saying, what are EF and FG? They don't say, hey, what's x? So when I plug that back in, I'm going to plug in 6 times 8 minus 14. Well, 6 times 8 is 48 minus 14 is going to give me a 34. Okay. Now, these are not two segments that are the same. So 6 times 4 is 24 plus 1 is 25. So that's where I get my EF and FG, plugging my value of x back in to 8x minus 14 and 4x plus 1. Now it's a similar problem just like the one we just did in 2a. So you're going to do 2b, you're going to set it up, you're going to write it out. I have 2a there. It's your turn. Go ahead, turn it off, and you try the work and see how you do. Okay, you should have started with jk plus kl is equal to jl. jk plus kl is equal to jl. Now I flipped it, and some people have a problem with this, but remember, it's just two numbers that'll equal a number that equals the addition of two numbers. But now jk is 4x plus 6, kl is 7x plus 15, and so now I'm able to plug those in for jk and kl. jl is 120, I get to pop that in, and now I have a sentence to be solved for x. So I combine like terms, I get 11x plus 21 equal 120. I subtract 21 from both sides and divide by 11, find out that x is 9. Again, reread your question and check it out. What are jk and kl? Well, jk represents this whole length, kl represents this whole length. So now I take this, I pop my 9 in, and I come up with 42. And I do the same thing. I pop my 9 in, I come up with 63 plus 15, and I come up with 78. These two must add together to be 120. And like these two did, add 34 and 25, they'd be 59. Okay, sliding on, we're looking at some other notation. Okay, congruent. Okay, please notice this symbol. It's an equal sign with a tilde on it. If segments or angles have the same value, we say they are congruent and their measures are equal. Notice the difference between congruence and equal. Okay. Now, if this is 1 inch and this is 1 inch, we can therefore say, although the measures are the same, and notice how we say the AB, the length between A and B, is equal to the length between C and D. Now, we could also, because these lengths are the same, because they're segments, I can say segment AB is congruent to segment CD. That's what segment AB is congruent to segment CD. Now, please notice that I have a segment on top of AB, and I call it segment AB, a segment on top of CD, and I call it segment CD. When it doesn't have anything on top of it, we're talking about the length between AB and the length between CD. Now, using the diagram at the right here, we have that number line. We have A, B, C, D, E points on that diagram. Are AC, and BD congruent? Those are segments. Now, to prove segments are congruent, the measures must be equal. So, I'm going to do the measures. So, I go, hey, you know something? I got A is -2. I've got C is 5. So 5 minus a -2, which becomes 7. BD, I've got 10 minus 3, or 3 minus 10, which is -7, the absolute value of which is 7. So because these measures are the same, I know that AC is equal to BD, the length AC and the length BD. So segment AC is congruent to segment BD. Now, I want you to do a similar check on B. Are segments AB and segment DE congruent? Go ahead and try it yourself. Now you've had an opportunity to check that. You got AB is, A is -2, B is 3, so -2 minus 3 is -5, absolute value of which is 5. DE is 14 and 10, so 14 minus 10 is 4. So AB is not equal to DE. Okay, therefore segment AC is not congruent to segment DE. And so we've been able to show that congruence and equality are kind of connected to each other. If two segments are equal, then they are congruent. Two segments are congruent, then their lengths are equal. Now, midpoint of a segment is a point that divides a segment into two congruent segments, a point, line, ray, or other segment that intersects a segment at its midpoint is said to bisect the segment. Segment bisector is a point, line, ray, or other segment that intersects a segment at its midpoint. Now, as long as it intersects the midpoint, AB, this means that AB and BC are identical in length. So that's the midpoint by definition of midpoint. So now if we're talking about midpoint, this is the difference. We're talking about a midpoint. Q is the midpoint of PR. What are PQ, QR, and PR? Now since we know that Q is the midpoint, the length PQ and the length QR are identical. So I should be able to say that PQ is equal to QR. And because they're equal, I can now plug them in and say, well, 7x minus 7 is equal to 5x plus 1. Now I just solve for x. Now notice I didn't have the full length of the segment at all because I knew 6x minus 7 and 5x plus 1 are identical in length, and I'm going to use that fact to solve for x. In solving for x, I find out that x is 8. Okay, I took and subtracted 5 from both sides, and then I added 7. And I found that x was 8. Now I'm going to check that. I'm going to plug in that x is 8. 6 times 8 minus 7 is 41. And I'm going to plug in that x is 8. 5 times 8 is 40 plus 1 is 41. So the length PQ, the length QR, and the length PR all can be found. So now I'm going to write those down because I was asked to find them. PQ, the whole length of PQ, which is equal, we just found out, to QR, if I can make that a Q, is 41 units. Now, the length PR happens to be 41 plus 41, which is 82. Now, it is necessary to substitute the value found for x back into the expression to determine the length of the other segments. Is it necessary? Well, yeah. Well, the other segments, we've got to put in, but no, since PQ and QR are equal, then you solve for PQ and you should know QR and PR, because if I knew this and I knew they're the same, but you know why I checked them both? Was that I wanted to make sure I didn't make a mistake. So yeah, you should double check your work. PQ equals QR, they should be the same. Okay, so make sure you just double checking your stuff. Your turn, figure out midpoint, turn it off, and then come on back. Okay, welcome back. Notice TU is equal to UV. 8x plus 11 is equal to 12x minus 1. So I solve and find out that 3 is x. I plug that back in to find TU, and I plug it back in to find UV. And now I know TV, which is 70. Now what I'd like you to do is check this out. Using 5 is kind of a check using our notation. And using the diagram below, name each of the following. Okay, the point of ray dA, that is 2 units from D. Notice this is a ray, and it's got a head with an arrowhead on one side, so it's ray dA. This is B, okay, 2 units from D. Okay, 2 units from D, ray dA, the point on ray dA from D to A, 2 units from D. B, it would not be F because it is not on ray dA, and it starts at D and goes through A. 2 points, 3 units from D. 2 points, 3 units from D. 1, 2, 3, G, and 1, 2, 3, A. As we go through, the coordinates of the midpoint of AG. AG, the coordinates of the midpoint. Now remember, coordinates of the midpoint is D. You know, the coordinate though, it should be 0. Remember, this is the coordinate, so we are actually talking about 0 here, so really what my answer should have been was 0. So many people say D, and they wanted the coordinate, and that's what the coordinate is. Okay, this is the point, and they don't ask for that. Okay, a segment congruent to AC, AC, any segment that's congruent to AC. Okay, BD or CE or DF or EG, all those would fit those requirements. Okay. Well, that's the end of notes today. It's 1-3, page 24, numbers 9 through 19, odd, 20 to 31, 39 to 41, 44, 45, 53 to 56. I hope things are going well. Make sure that if you got questions, you talk to me about it. I can't make any changes based on your understanding unless I know better about what's going on. Thank you, and have yourself an excellent day.